Well, hello guys and welcome back to Mr. G Physics, the channel that is going to help you to improve your marks in physical science. Here is Mr. G, and today we're going to do a video for the grade 11. This one is going to be about electromagnetism, and we're going to do an experiment throughout the video. What is physics without experiment? Just another boring subject. So we're going to be doing today electromagnetism, and most especially the magnetic field that is generated around a conductor. 1820, a Danish physicist, Christian Ørsted, was doing experiment. He was studying and doing experiment, and accidentally he noticed that when he let current flow through a conductor, then a needle of a compass deviate. So you know that if you have a compass, the only way to deviate if there is a magnetic field. Let's, for example, if we have that compass, you know that compass is going to be deviating according to the magnetic field of the Earth. However, that compass is going to be deviated if I approach a magnet. Alright, as soon as I approach a magnet, you can see that that compass is going to deviate if there is a presence of a magnet, as you can see here. So now, what did Ørsted do? Well, he let an electric current to flow through a conductor, and he noticed that there was a magnetic field. We're going to repeat that experiment, guys. Physics is nothing without experiment. It's not fun. Okay, so here we have all the apparatus that we need to do that experiment. If we look here, we have here a conducting wire, which is a rounded one, as you can see here. And then we have batteries. We have some batteries here. I'm going to show you right now. They are the batteries there. We have conducting wires to connect those batteries. Now we have the specific thing. We need a little bit current, so we're going to connect these batteries in a parallel. Okay, so it's going to be as following. These two batteries are going to be in series. These two batteries are going to be in series, but they are going to be in parallel. To make that one, I make at this point that the positive is connected to positive. This one is to connect the two positive. Alright, so making like this, in a parallel circuit, the battery, what is going to happen? They will have the same potential difference, but they will have more current. Alright, you know that from electric circuit when you done it. So here we're going to do the following. We're going to connect the negative side of one side of the battery to the negative of the other side, which make us to be in parallel. Positive to positive, negative to negative. This connection is in parallel. The idea of the parallel connection, as we said before, is just for increase the current. Okay, so we're going to connect one side of the conducting wire we have here to this side of the this connecting wire here. You can see the current is going to flow inside direction. The positive is in the center, so this one is going to be moving, let's say, anti-clockwise. Okay, but the current is going to circulate all the way there. And then the positive side of this conducting wire, which they are together, are going to be connected to this side here. All right, that is what is going to happen. Okay, I hope you can see properly the connection. Let me maybe move it to the other side. You can see there is some sparks. It means there is current. So let's make this one, press it a little bit. There we go. And now this one is going to be connected to this side of the battery. There is sparks. I hope you saw the sparks there. So we're going to disconnect because it's now is working. So now to see if there is a magnetic field, we're going to use a compass. So we're going to take this compass and we're going to place a compass there, and you will be able to see it just now. Okay guys, so here is the compass, and then you can see that if I move this compass from one side to another, there is nothing happen. The needle stays the same. So I'm going to close the circuit now. Then now the compass starts deviating, and you can see that that compass, wherever I move, is deviating accordingly to the conducting wire. You can see there in that specific way. If we move to the other wire, then you can see that is moving. But now, important, if you note carefully, that magnetic field is not pointing towards the wire, rather it's going around the wire. So if I move it to anywhere I put it, you can see it's going all the way around the wire, but not towards the wire. Okay, so maybe there you can see better. You can see anywhere I move that specific magnet, you can see if I move it here, it go all the way around this specific wire here. All right, so there is a magnetic field associated, and we can see it with the compass. But how does it look exactly? So let's see what we can do. We're going to now spread a little bit of ion filling around that conducting wire and see what happened here. Okay, so that is the two wires, and all I did was add in some ion filling. Now the circuit is open, so there's not current flowing. If I place the compass, you can see the compass is not deviating, it stays in the same place. Okay, you can see it there. But now, what if I close the circuit? And this time I'm going to close it at the bottom. Let me connect this wire here, but then let's close it at the bottom. There you cannot see that wire too much. So I'm going to close the negative, the positive side of the circuit. And let's see what happened, guys. I close it there. You can see the compass start deviating, but now if I click this one, ooh, there we can see the magnetic field pattern, more or less. You can see the magnetic field pattern that is circulating around this specific wires. You can see there is circular around the conducting wire. Now, obviously, we cannot see the direction here. We can use a compass to see the direction. In this case, if I place it, you know that the compass is pointing to the north. So if I circuit here, is pointing in that direction. So in this case, here is pointing anti-clockwise, and if we go to the other side, is pointing also clockwise. That one is clockwise, this one is anti-clockwise. Okay, so we cannot use a compass all the time to determine the direction of the magnetic field. We have a rules, and for this we are going to use something called the right hand rule. Now the right hand rule is quite simple, guys. All we have to do is to take the, let me move my face to this side here so you can see it. All we have to do is to grab a conductor. So if you grab a conductor, it will tell you in which direction is the magnetic field rotating around that specific wire if there is an electric current flowing. Remember, the magnetic field is only there if there is a current flowing through the conducting wire. So what we have to do is to identify the direction. So with the thumb, you point in the direction of the current, and when you grab that conductor, you have to grab the conductor. So if my conductor is in this way, I have to grab the conductor. So thumb there, and then I grab the conductor. So in this case, it will be rotating in that specific direction. But let's quickly go back to the experiment. If we apply the right hand rule in this case, the electric current is flowing down through this conductor because the positive is at the bottom, so it's going to circulate all the way up here, go all the way down around this way. So if we use the thumb and we point the thumb up here, we see that the magnetic field will be rotating in this direction, a specific direction like this, pointing in the anti-clockwise direction if we use the right hand rule in that specific case, guys. Okay, so let's see. Let's apply the right hand rule to this case. We have a conductor which the current is moving down, which is the same case as the experiment. If we apply the right hand rule here and the thumb is pointing down and you grab the conductor, you will get the conclusion that the magnetic field is rotating in this direction, circular all the way around the conductor in that specific direction. That is, if you apply the right hand rule, it will give you the direction of the magnetic field all the way. All right, so this is what we done just now with the right hand rule. Now, what else? Sometimes you can have a conductor where you only see the point of that conductor. In this case, this conductor could be represent the direction of the current with either a cross or a dot. So if it's a cross, it's because current is going towards. So in this case, current is going in. Current is going into the book. But if it's a dot, then the current is coming out. And let me maybe erase at this I and write current. Not somebody think I speaking about myself. All right, so if you apply the right hand rule, in this case, the thumb will be pointing towards or on the page. And if you apply that right rules, so you will see that it's rotating around that conductor in this specific direction all the way. I don't want to take off that
written there. In this case, then it will be circulating also around the conductor in this specific direction there. Guys, this is how to determine the direction of the magnetic field by using the right hand rule.
Now, sometimes we have a combination of many of these loops. All right, so instead of only one coil, we have like many coils together. This is called a solenoid. I have here one example which I want to show you here in camera. There is a solenoid. You can see there is like many coils together. Let me just focus this one a little bit. There we go. That is like many turns. It's a coil that have many turns. So the magnetic field of each of those turns will add up and will make like a magnet, like a permanent magnet. That is what is going to happen. So the solenoid will look like this one here. Now, the same right hand rule can be applied, but it's easier if you do the following. Now, in this case, the thumb will give you the direction in which the magnetic field will flow, and then all the other fingers, when you round the solenoid, that will give you the direction of the current. All right? And guys, this is all about electromagnetism. This is quite simple. We have to just practice some questions. I hope it helped. If it helped, thumb up, subscribe for the channel, ask questions. I'll see you next time. Mr. G.